Now we're going to discuss end behavior models, which, as I mentioned in class, are incredibly useful for real life. We're going to look at number 40 for an example here. We have negative 4x cubed plus x squared minus 2x minus 1. Now, in a real life situation, that is a lot of stuff to remember. All of that at once, it'd be hard to memorize, hard to communicate to someone that's working with us. So instead, we're going to use an end behavior model to approximate this function right here. So let me show you here that this first example is a typical polynomial function. And so here's what we do to find an end behavior model for one of these. They're very simple, as long as it's a polynomial only. So there's no trig functions, there's no exponentials, there's no inverse trig, there's no logarithms, there's only x to a power. There's only those types of things. When you have that type of situation, all you have to do is use the highest degree term, and that is your end behavior model, which in this case would just be this negative 4x cubed. Now, we're not using it because 4 is the largest number. We're not using it because it's out front. We're using it because of this power right here. That's the largest power, so that's going to be the one that we use. So that will be our end behavior model, and let's look and see why this is useful. Now, the green curve here, this is our original curve. This is the longer one with that also has the x squared and the negative 2x and the negative 1 in it. And there's the original curve. Here is our end behavior model next to it. Now, they are not identical, but here's what you need to notice. If you'll notice, the place that they don't look similar is just actually around x equals half and then back to about x equals negative 1/3. But as we zoom out, what you see is these two curves basically lay on top of one another. So if we are talking about something that's even in the hundreds or thousands of units, negative 4x cubed is such a close approximation of the original that it's much easier to use. So that's how we do a basic polynomial end behavior model. Now let's look at what we do with a rational function that needs that we need to have the end behavior model for. Now on this one, I went ahead and used the same polynomial for the numerator of this, but we can see here the reason this one is different is it's rational, which means that it's written as a fraction. That's all that means. And so we have a polynomial on top, a polynomial on the bottom. Now we are still going to work this very similar to what we did just a moment ago, in that we're still going to take the highest degree term on top, but now there's a bottom to work with, and so we take the highest degree term on bottom as well. And actually, let me go ahead and add a little bit more to this bottom just so you can see this. So maybe it's plus x minus 79. But we're still going to take the highest power down there, which is in this case the 2x squared, and we're going to put it in the bottom of this one. Now, we have to simplify here. So negative 4 over 2, negative 2. And then the x cubed over x squared, we just subtract the exponents and get x there. So this huge complicated fraction here, again, if we were to zoom out, we would see that its graph is basically identical to the graph of negative 2x. So negative 2x would be the end behavior model. Finally, we want to look at what we do in order to find the end behavior model for a function that is not a polynomial or has some elements that are not polynomials. And here would be a good example where we have e to the negative x plus x. So here is what that graph looks like, e to the negative x plus x, and you'll notice here one side kind of has one shape, the other side has a different shape. And so what we're going to do is, and let me get rid of that, is we are going to type in one part of the function at a time. And by one part at a time, what I mean is we're going to type in the first part, e to the negative x, we're going to type that in as one of our y equals. We're going to take the second part, the x, type that in for another part of our y equals. So we're going to do that right here, e to the negative x. And it's going to be in blue. Now, what you can see here is that on the right-hand side, the blue and the green look nothing alike. But the left-hand side, especially as we zoom out, they collapse on top of one another, and they're basically the same thing. So e to the negative x is going to be part of our end behavior model. And we're going to say that it is our left-hand behavior model. So let's put that out here next to it. that it is the left hand in behavior model. And then the y equals x, you can probably go ahead and guess, is going to be the other side. So let's type that in and see what it looks like. So here's y equals x. And we see that on the right-hand side, it's the same as the green. So it will be the right-hand behavior model. And we'll type that in here.